Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we are going to talk about solving inequalities with one variable, okay? Later on in the year we'll talk about solving equations and inequalities with two variables. But let's talk about these inequalities. First of all, the good news is that all of the skills that we learned for solving equations are valid with inequalities. There's just one exception, and we're going to get to that exception in a little bit. But before we even start talking about solving inequalities, we got to talk about inequalities in general. I want to give you some vocabulary words. I want to give you some usage explanation. And really important, I want to teach you how to write solutions for inequalities in two different ways. So let's get right to it. First of all, equations use an equal sign, okay? That's why you have equations, equal sign. That's equations. But inequalities use an inequality sign, okay? And an inequality sign is such as less than would be less than. Greater than looks like that. I'm not trying to be sarcastic, but think back to when you were in younger grades. The alligator eats the big number, right? Well, you have less than, you have greater than, you have less than or equal to, and you have greater than or equal to. Notice that less than or equal to and greater than or equal to have this little line down here because it could be equal to the value as well. So when something is less than or equal to something else, it's either less than that value or equal to it. Same thing with greater than or equal to. And then there's also not equal to. And not equal to is simply an equal sign with a slash through it because it's not equal to that. Now, when dealing with word problems, okay, you got to remember the following, okay? At most means less than or equal to. For example, Mr. Morrow is at most 40 years old. Means that Mr. Morrow is 40 years or less. So Mr. Morrow M is less than or equal to 40 because I'm at most 40. So whenever you see in a word problem, the word at most, it's less than or equal to. When you see is at least means greater than or equal to, okay? So at least means greater than or equal to. For example, Mr. Morrow is at least 40, means that Mr. Morrow is 40 years old or more. So Mr. Morrow M is greater than or equal to 40. Okay. Now, as far as how we write the solutions to inequalities, there's something called set builder and there's something called interval notation. Set builder notation is the basic way of writing inequality solutions. And this is how it works. Let's say we're solving for the variable x, okay? When we have a set builder, we're creating a set. So we have our little braces. We define the letter that we're solving for. Then we draw a straight vertical line down, and then we actually put in the solution, whether it be x is less than a, x is greater than a, x is greater than or equal to a, or x is less than or equal to a. Please note that whenever you're reading inequalities, you read from the variable in question. You never read from the number, you read from the variable in question, and I'll explain what that means right now. Write each solution using set builder notation. Well, again, what I mean by reading from the variable, this is x is less than 5. You do not read 5 is greater than x. No, no, no. It's x is less than 5. So I'm going to create a set notation here, set builder. So I have my little braces. X is what I'm solving for. My straight line, x is less than 5. It's that simple. X is greater than or equal to -2. Well, I have my braces. I'm solving for the variable x, and x is greater than or equal to -2. This is set builder. X is greater than 3. So I create my braces. I'm solving for the variable x. I draw my line separating the solution, which is x is greater than 3. Okay? And sorry about that. You have to wrap this up with another brace. And that's set builder, literally. Now, interval notation. Interval notation is a fancy way of writing inequality solutions. And here's how it works. When you're dealing with less than or greater than, I want you to only use, well, not that I want you to use, you have to use always, when you're dealing with this, you're going to have to use parentheses. When dealing with less than or equal to or greater than or equal to, you are going to literally use brackets. And please note, very important, always use parentheses for either plus or minus infinity. Infinity is a value that never ends. Infinity goes on forever and ever and ever. So we can't really have an equality to infinity. So whenever we're dealing with inequalities that have infinity, infinity will always be encapsulated with parentheses, never brackets. When using interval notation, you have to remember also that the format is always the same. It's the small value, comma, the larger value. That's the way it goes. So for example, write each solution using interval notation. Okay, I've got x is less than 5. I need to use interval notation. Now, sometimes it's difficult to understand how to write this interval notation. So what I tell my students to do is to sketch a quick graph of it. So x is less than 5. If we sketch a graph here, let's put our 0 as like a beginning point, and then we have 5, right? Okay. So I know that it's less than 5. So I know that it's all of these numbers to the left of 5. So x is less than 5. How do I write that in interval notation? Well, if I keep going over here to the left, am I not getting more and more and more negative? Eventually, the furthest negative I can get to is negative infinity, right? So x is less than 5 would be written as parentheses, negative infinity to positive 5, close with another parentheses, because I have less than. If it was less than or equal to, the 5 would have had a bracket around it. That's interval notation. This tells the reader, hey, x is anything less than 5. X is greater than or equal to negative 2. If we look at our little sketch here, we've got a 2. It's greater than or equal to. So if you remember from middle school, close that circle. You're going to the right because x is greater than or equal to up. And I did it wrong. Pay attention. It's negative 2. My bad. So negative 2. So if you remember from middle school, close that circle up because it's greater than or equal to. You shift it to the right. And now I have bracket negative 2, comma, to positive infinity. Why bracket? Because I had it greater than or equal to. Why did I start with negative 2? Because that's my smaller value. Why did I end with infinity? Because this arrow keeps going on forever, 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 all the way to positive infinity. X is greater than 3. Well, let's sketch this out as well. We've got a 0, we've got a 3, it's greater than, so it's an open circle. You shade it to the right. So I'm going from 3, but it's greater than, not greater than or equal to, so it's a parentheses 3, that's my small value, all the way to positive infinity because it keeps going on and on forever and ever. And that is interval notation. Now, graphing inequalities. We had a little brief review of graphing, but now we're going to do it correctly, okay? When graphing inequalities, remember that when dealing with less than or greater than, just like interval notation, you want to use parentheses. Back in middle school, you probably used an open circle. That's okay, but parentheses is really the way we want to go now. When dealing with less than or equal to or greater than or equal to, you want to use, just like interval notation, a bracket. I know that back in middle school, you probably used a closed circle, which is fine, but let's get more professional, and it will be brackets. And again, as always, you're always going to use parentheses for plus or minus infinity. So at the end of solving equations, you have these solutions. I want you to graph each solution. So x is less than 5. Well, draw a little number line. Mark your 0 as your starting point. You know, that's like a reference point rather. X is less than 5, so we got 5. it's less than. So I'm going to use a parentheses, and it's less than. So it's everything shaded to the left. If I wanted to write this in interval notation, this would be, I'm going from negative infinity to 5, parentheses because infinity always has parentheses on the 5 because it is a less than, not less than or equal to. Number 2, x is greater than or equal to negative 2. Here's my 0, here's my negative 2. We have greater than or equal to, so it's a bracket. It's greater than or equal to, so I'm going to go to the right. Okay? If I wanted to write this in interval notation, I'm going from negative 2 to positive infinity. Why did I use a bracket for negative 2? Because it's x is greater than or equal to negative 2. X is greater than 3, my reference point of 0, here's my 3. It's greater than, so I'm using a parentheses, and it's greater than 3, so I'm going to the right forever. In interval notation, this would be 3 comma positive infinity. Last but not least, x is less than negative 4. So my reference point of 0, here's my negative 4. It's less than, so I have a parentheses. It's less than, that means it's going to the left forever. So in interval notation, this would go from negative infinity to negative 4, both in parentheses, because infinity always has parentheses, and it's less than, so less than has parentheses as well. Okay, so now we know how to graph them. We know how to graph inequalities. We know how to write the solutions of inequalities in both set builder and interval notation. Now, let's solve some inequalities. In order to solve inequalities, simply use the same procedures for solving equations, except the following, y'all. Whenever you multiply or divide by a negative, you must flip the inequality sign. Now, please notice that I circled the word by, I capitalized the word by. When you divide by a negative, not when you divide to a negative. And I'm going to explain that right now. Solve each of the following inequalities expressed in interval notation, then graph the solution. Okay? So you want to solve it, you want to express it in interval notation, and you want to graph. So first things first is a one-step equation. I isolate this x by dividing by negative 2. I don't care that the 10 is negative. I don't care about that. You know, I care about that as far as knowing the proper sign, but I don't care about that as far as flipping my inequality sign. What I do care is that I divided by a negative 2. So this will be x is greater than 5. Why did this flip? Because I divided by a negative 2. Interval notation, well, in order to get interval notation, I'm going to graph it first. So here's 0, here's 5, parentheses, it's greater than. Oh, okay. Now the interval notation is pretty much written for you. You have a parentheses 5, and I'm going to positive infinity forever. Boom, done. Here's the solution, here's the graph, here's interval notation. Okay, number 2. Oh, this looks messy. Don't be afraid of this. This is the same skills that we used before. Common denominator here is 15. So I'm going to multiply 15 to every single term in here. There's nothing in parentheses, so nothing gets left out. So 15 times 4 thirds, 15 divided by 3 is 5, 5 times 4 is 20x. Minus 15 times 2 is 30 divided by 3 is 10. Less than or equal to 15 divided by 5 is 3. 3 times 4 is 12x. And 15 divided by 5 is 3 times 3 is 9. So now I solve by subtracting 12x to both sides, just like normal. So I have 8x minus 10 is less than or equal to 9. Let me go ahead and just push this guy down a little bit. So now I'm going to add 10 to both sides. And I have 8x is less than or equal to 19. Divide by 8. Sorry about that. Let me go ahead and just give us some more space. So I have 8x is less than or equal to 19. I'm dividing by 8. I do not flip the inequality because I did not divide by a negative. So x is less than or equal to 19/8. So x is less than or equal to 2 and 3/8. It's always easier to graph mixed numbers. Okay? So now let's graph it. Here's my 0, my reference point, and I've got 2 and 3/8. So here's 1, here's 2, here's 3. 2 and 3/8 is about here, and it's less than or equal to, so it's a bracket. Actually, it should go the other way because it's less than or equal to. So here's 1, here's 2, here's 3. My bracket this way, it's less than or equal to. So I'm shading to the left. That already gives me my interval notation because I'm going from negative infinity to positive 2 and 3/8. A bracket around 2 and 3/8. Why? Because there was a less than or equal to sign. Okay? Let me go ahead and clean this up a little bit so I can get 4 here. Sorry about that. All right. So that's that guy. Let's move 4 back over here. Okay, next, number 3. Well, I'm going to first of all combine the x's. So I'm going to subtract 5x to both sides. I got -3, then I've got a negative x. I'm going to divide -1 to both sides. So here's with 3. This sign flips. Why does it flip? Because I divided by a negative. Now be careful here. I know that we read left to right, but when we're dealing with inequalities, we read from the variable, So x is greater than 3. Here's my graph, 0, 3, parentheses because it's greater than, and I'm going to the right. I already have my interval notation pretty much. This is 3 to positive infinity. Why parentheses? Because infinity uses parentheses, and I had a less than. Number 4. I got to distribute here first, just like equations. So I've got 12x minus 24 plus 12 is greater than 11x minus 13. Let's clean this side up here. I've got 12x minus 12 equals 11x minus 13. I'm going to go ahead and add. I'm going to go ahead and add 13 to both sides. So I've got 12x plus 1 equals 11x. I'm going to subtract 12x to both sides. And I'm sorry, it's not equals, it's greater than. I'm going to subtract 12x to both sides. So I got negative x is less than 1. But I don't want to solve for negative x, I want to solve for x. So I divide by a negative to both sides. So I've got -1. I divide it by a negative. I got to flip that inequality. And again, I'm reading from the variable. X is greater than -1. Here's my 0. Here's my -1. It's greater than. So bracket. I'm going to the right. I pretty much have my interval notation here. I'm going from -1 to positive infinity. Let's go ahead and clean this guy up as well. Let's see here. There we go. All right. Let me group this together. And then let me group that together. Okay, and there you go. All right, 5 and 6. Number 6, easy peasy. Divide by 6 to both sides. Y is greater than -7. Here's my 0 reference point, -7 over here. Y is greater than, parentheses, shade to the right, interval notation. I'm going from -7 to positive infinity. That's it, I'm done. And last but not least, I've got -4/3 x is less than or equal to -4/5. So I'm dividing here. I've got to divide by 4/3. Or just multiply by the reciprocal of negative 3/4. But if I'm multiplying by a negative, remember what happens? I have to flip the inequality. So this becomes x is greater than or equal to, the 4's cancel, positive 3/5. My graph for this guy is 0. Here's 1. 3/5 is about here, and it's greater than or equal to. So I'm shading to the right. This is my 3/5. And that's my interval notation. I've got from 3/5 all the way to positive infinity. And there you have it, guys. One last thing, just to make sure this is clear. It's when you divide by a negative that you flip. So for example, if I have 2x is greater than negative 10, I divide by 2, my answer is x is greater than negative 5. I do not flip there. But if I have negative 2x is greater than 10, and I divide by a negative 2, then x is less than negative 5. I had to flip it because I divided by a negative. I don't care what I'm dividing to. I care about what I'm dividing by. And there you have it. Hope you guys learned a lot. Thank you so very much for watching and have a wonderful day. Bye-bye now.